Hello and welcome to my class. Um, Today we're going to talk about reading data in from file systems and mostly reading in from MySQL. And if you have any questions, you can always write to me at this address. I will be checking this periodically, and I also have some help files available on this website. First of all, we're going to talk about reading in data or writing data to a text file. And when reading in from a text file, you have to define a file variable. And in this example, I'm calling it planet file. And for a text file, you just put a colon text. And that's all that is required. You have to then go ahead and assign that variable to a physical file. In this case, it's planets.txt, which is a text file. And I can show it to you. It has the planets and semicolon, and then how far they are from the sun in astronomical units. So after assigning the file, the first parm is the variable, and then the second is the physical file name. We then issue a reset, which will set you at the beginning of the file, and then you can just issue readlines, with the first variable being the file variable, followed by a buffer area, which is just a string. It's defined here as a string, and you just do readlines to access, and I have it in a repeat loop, and there is a function in string utils called extract word, and based upon using the semicolon as a separator, it will grab first, second, third, fourth variable within such. And here I'm just doing one for the planet name, number two to get the astronomical units, but then we have to convert the astronomical units from a string to a floating point. And then we can calculate the period by raising it by 1.5, and that will tell you how long the year is on that planet. And then it just writes it out to the screen. And then it will read the next line from the buffer, or into the buffer. I can show this works. As you can see, the Venus and Mercury are sub 1, and Mars and the planets afterwards are in excess of 1, with Pluto being almost 250 years to for the 1 year on Pluto. Text files are convenient. A lot of data will come to you as a text file. They are relatively fast, but you only can access the data sequentially. If one person is reading from that file, or one process, no other process can. And it only has single point security. Only the operating system would prevent someone from copying your data. There is a binary structured file, which is very similar, at least to access it, but it is a little bit more complex. A binary file actually, you have to set up a record to define what's in the data. And in this case, we're saying planet name is going to be a string of 10, and AU is going to be a double. Yes, you can have actual doubles or other binary types within a binary file. And then when we define the file variable, which I have here, we are going to say it is of type planet record. File of planet record. So it's going to be files of this structure. Again, just like with the text files, we have to assign it to a physical file. Planets.dat is what planet file is connected with. We're going to do a reset to the file variable. If we were going to write to it, we would do a rewrite. And yes, you can access binary data in a random function, so you're not limited to just sequential, but it is a primitive file system, but it is very fast. An i5 with a hard disk drive can write about 200,000 binary records per second. This compares very nicely against other different types of files. It has no built-in ISAM. Back in the day, we used to use an array or a linked list to connect it with a specific record, and then you would issue a seek to go and find that record. By the mid-90s, these had fallen out of favor, and no one uses them much anymore, to my knowledge, but it is kept there for backward compatibility, in my opinion. Single user access only, so if one person is doing something with it or one process, no other processes can access it. And there's a single point of security, basically the OS, again, just like text files. And we can compile this. And it is something to keep in your back pocket, but I wouldn't spend an inordinate amount of time on it at this point. The third type of file that I wanted to talk about is probably the most complex to use. It's accessing an SQL table. And this is where I want to refer back to my website. So down here on the associated.html, I have some MySQL Pascal include files. The first one is dbconst.inc, and in here I have my user set up to, in my example, it's just my name, Terry, and then my secret password, which I really don't want to show you, so I just have this out here like this. You would put your secret password in there and your user ID to access the MySQL. And then we have some a couple of functions and a procedure, and I keep this in a file called MySQL connectlive.include. And I don't want to go into the details of here how it works, but it does work. So if you go to the help document, this has some stuff that you have to include if you're going to access a MySQL table in a command line program. The first line is going to be what libraries have to be included. Which I do have here. Now that MySQL 80CONN, that will change over time as MySQL gets updated. Currently we're on version 8.0, so that's where the 8.0 comes from. Probably when they go up to 8.1 or something like that, you would have to change those digits there. Followed by the two include files, which I copied from here. You don't have to include the // that's just a comment. So it's just the two lines. Now this is going to have to point to where you saved them on your system. This is where I saved it onto my system. And then we have to include some variables. One needs to be a TSQL connector, one needs to be a TSQL transaction, and one needs to be a TSQL query. These were defined in that second file I had you create. And here I have put them into my program. I renamed my connector to pconnect for planet connection, ptran for planet transaction, and pquery for planet query. Then finally down here, I have the outline of a program that would just do a select, which is all we're going to do here. So you could copy and paste this right onto here and then change the variables to whatever you change the variable names up here. And the first line is going to be this connection. And you first have to tell what version of the server you're going to be using. And in this case, it's MySQL 8.0. Next is going to be the IP address to connect to the MySQL server, which is running local on this computer. And 127.0.0.1 is the local address, local IP address on your computer. The third thing is going to be the database you want to connect to. And I just threw some associated tables into this example DB. And then the my user and my password, which were defined in this DB constant not include. After you then you will need to, after you run those first three statements, the second statement is a create transaction, the third statement is your pquery, where you actually create the query. You're going to need to assign a valid SQL statement into pquery.sql.text. The .sql is a subfield within pquery, which is an object-oriented data type, and text is a subfield within .sql. You're going to open your connection then, open your query, and then you're going to do your repeat until pquery.eof, which is another subfield within pquery. To access each column within that table, we're going to say planet, which is a string, is going to be equal to pquery.field by name, which is a subfield within pquery, and then we're going to, in parentheses, have the column name, and after the parenthesis, you're going to have a dot as string telling it what type of data to expect. AU, which is a double, is going to also be pointed to pquery.field by name, but in this case it's going to be the field AU, and we're going to tell it it's as a floating type using the dot as float. Then we're going to do our calculations like we did in the previous programs, and we're going to just write it out to the command prompt. And then we're going to issue this pquery.next, which will take us to the next row within that table. And finally, after the pquery.endofile, we're just going to do some cleanup, and then the program should exit. And that came from the SQL table. And if we go back to our MySQL help document, down here, I have provided some additional help information. If you take the query variable and put a dot first, that will take you to the first row of the data set. A dot last would take you to the last row of the data set. Dot prev would take you to a previous row, and of course dot next takes you to the next row. Down here at the very bottom, I have what the logic involved to do an update or a delete, which we will look at next or a little later. If the way I have my MySQL server set up, in order to create a database or to delete or add a table or change a table structure, you have to do that as root. If all you're doing is selecting, updating, deleting, you can use the regular user. So that's why I have this tabbed command prompt up here. To get in as root, you just do the sudo command, followed by the word MySQL, that gives you access to the client. You put a -u for root, and you do not do the -p. When you do the sudo command, it will prompt you for your super user password. And now we're in. You can do a show databases. That will show you what databases you have out here. And I can create a database. And I want to create something called states. And then we're going to use And if I wanted to show what tables were available here, I can just do a show tables. And it shows that there's nothing out there. It's an empty data set. Now, if you want to go and create a table, I prefer, my method is just using a text file to have the SQL and just execute this from the client. There are special apps that are available that gives you a GUI way to do this, but this works just as well. Now I created a row, state name, a varchar, which is just text data, a string per se, and then I have to give it what the maximum length would be, followed by a comma. And then I also wanted to create another varchar, much smaller, which would hold just the state code. There is also a char type, but it will use the maximum amount of space that you requested every time. While, let's say, state name was just Iowa, it doesn't need to be 20 long, and it will try to save you what space it doesn't need. So this would be a large database with the state information in it would be smaller if you use varchars instead of just chars. I also went ahead and created an EV row of type integer, int, and I gave it a length. You don't have to. And finally, at the bottom, I made the statement to create a unique index. I gave it the name state IDX, and it's saying on the table state, and it's going to use as the index state code. And we can go ahead and execute this by just doing a backstroke period and then this file name, which is createstate.txt. And if there were any errors, it would have told you so. But everything was successful. Now if you do a select on that, it'll tell you it's an empty set. Now in this program, we have the standard libraries copied right from this line with one addition. We are including string utils. The two include files are here just like before, and the three variables are also defined here. just like beforehand, we had defined, we had run those procedures. But in addition, we're also assigning a text file to a file variable, input file of text. We're doing a reset because we want to read it sequentially. And we're going to read line into a buffer, which is just a string. Now, there is a procedure within string utils. I have showed it to you before. Extract word, where it's going to separate the data on semicolons. Here is that file. It's the state name with a semicolon, and then the state code and a semicolon, and how many electoral votes. So we're going to say while not end of file of input file do. It's going to read that. First, it's going to grab the state using that extract word. Then the state code, and then finally electoral votes. And then we're going to format this insert statement. Insert into state, then in parens, the three columns, and then followed by a value, and then in parens, state name, state code, and then EV. Now the string data needs to be quoted, and that's why we use this quote string function, which is also in string utils, and follow it by a comma, quoted string of state code followed by a comma, and then EV, which does not need to be quoted because it's a number, and then a right paren. Then we're going to put in our query variable, which again is a object-oriented data type, in SQL.text, and we're going to import that query right into there. And then we're going to issue an execute SQL. We're going to do a transaction.commit, and then do a readlin to get the next buffer area. And that comes right from here. It shows to add the SQL into that variable. Then do an execute SQL, and then the transaction dot commit. So that would insert the states right into our table that we just created. And if we try to do a select on that data right now, it's an empty set. I believe it is just state DB. No, it states. So if we go compile it, and then try to run it, it took a second or so. And as you can see, we've got data out there now. It is possible to update that information. And here I have a program that it does all the things that other program did as far as the setup and such. The uses is here. The include files are here. My special variables are here. And the connection and all that stuff that we had done is here. Here we have an execute SQL and then the commit. But what we're doing is we're setting the query up to actually just update the table. We can do an all, which would update all of them, or we could put in the state code there for a specific one and then tell it how much to increase the electoral votes by. So if we go back and look what we had before, we can see that Texas had 38 electoral votes. And if we go to run this program, and tell it we want to use Texas, and let's increase it by 10%. If we do a select, we can say, just so we don't have to look at the whole thing, And Texas is now up to 42. And it looks like it rounded. If we looked at the rest of the data set, we would see that the rest look very similar to what they had beforehand. They were not changed, like Wyoming's still 3, Iowa's 6, and it was 6. So everything is as expected. Now, if we went ahead and increased all of them by 10%, we can see that, let's say, Tennessee was 11, even though we didn't mention Tennessee. It's now 12. So the rest should have been all increased by about 10%. Deleting isn't much different. To delete the whole data set, we just say delete from state. If we want to do just a state, single state, we could say delete from state where state code equals something specific, like AL for Alabama. We can go ahead and compile this. And if we just do TX, Texas should be gone. I did that wrong. So if we do our select again, Texas is gone. If we go and do an all, they should all disappear. And it's now an empty data set. So that's the basics of accessing an SQL data set. I don't know the exact settings for PostgreSQL. But for PostgreSQL, this variable would be different. It would be like Postgre and then a version number maybe. I have done it in the past, but it's been a long time and I do not recall. And the version numbers since then would have changed considerably. If you're wanting to use another database server, you're probably going to have to do a little bit of research. Any questions about what I have discussed here? Write to me at this address. Thank you.